Exploring quadratic equations. Introduction. Good morning, everyone. Today, we're going to dive into the world of quadratic equations. Quadratic equations are an essential part of algebra and have various applications in real life, from physics to engineering and even art. By the end of this class, you'll have a solid understanding of what quadratic equations are and how to solve them. Definition of a quadratic equation. Let's start by defining a quadratic equation. A quadratic equation is a second-degree polynomial equation in a single variable, usually written in the form x squared plus bx plus c equals 0. Here, a, b, and c are constants, and x represents the variable we're trying to solve for. Exploring the components. In the equation x squared plus bx plus c equals 0, a is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is the constant term. The solutions for x that satisfy this equation are called the roots. Nature of roots. The nature of the roots depends on the value of the discriminant, which is given by the expression b squared 4ac. If the discriminant is positive, the equation has two distinct real roots. If it's 0, the equation has one real root, a repeated root. And if it's negative, the equation has two complex roots. Methods to solve quadratic equations. There are several methods to solve quadratic equations: factorization, using the quadratic formula, and completing the square. Let's briefly go through each one. To solve by factorization, we look for two numbers that multiply to ac and add up to b. We then express the middle term as the sum of these two numbers and proceed to factorize the equation. The quadratic formula is an elegant way to find the roots of any quadratic equation. For the equation x squared plus bx plus c equals 0, the roots x are given by x equals b plus or minus square root b squared 4ac, 2a. Completing the square involves transforming the equation into a perfect square trinomial and then solving for x. This method is particularly useful for deriving the quadratic formula. Let's work through some example problems together to see how these methods work in practice. Quadratic equations appear in various real-world scenarios. For instance, they can help us model the trajectory of a projectile, the shape of a parabolic dish, or even the profit optimization for a business. So, in this class, we've covered the basics of quadratic equations, their nature of roots, and different methods to solve them. Remember that practice is key to mastering this topic. Keep practicing solving quadratic equations, and you'll become more comfortable with them over time. Your homework for tonight will be to solve the exercises from your textbook related to quadratic equations. If you encounter any difficulties, don't hesitate to reach out for help. That's all for today's class. I hope you found this introduction to quadratic equations informative and interesting. If you have any questions, feel free to ask. Have a great day, everyone.